Hey, testing. Welcome to the dojo. Down with a sick float. You already know my name's Dark Mage. What's up? I'm fucking around with Flamegraphs and want to do some examination at my existing code base and see where there might be some slowdowns. Where might there be places that are like not optimized? Or like, are there places that can be written better? Can I improve how fast my game runs? Because it feels fast. There's relatively little lag, but over time things will scale, and we're going to end up seeing that there will be bottlenecks during execution. Very interested in finding those. Why not? Let's do that together. Let me just double check something here before I get started. And I think we're good. All right, so let's hop over here for a sec. Not for a sec, but like this is where we're gonna hang out for most of today, right? So this is my game code, obviously. Y'all have seen it plenty of times before. What are we doing here, though? So I learned about this. I've known about Flamegraphs for years, but I always have to remind myself how they work and how to like actually use them or how to like actually generate them, right? So while the game is running, we want to do like a perf record here. I'm going to take a separate one because I've taken a sample one earlier today, but I want to take a second one here. So to do that, I'm going to repeat this command right here. I'm going to go perf record all that stuff, and I'm going to do it out too. Now, we're not running the game at the moment, and I'm actually going to set this up to run for like 3 minutes. And actually, we don't even know. We'll do like a 3-minute run, right? But also, I want to do some tweaks because we're going to see that like under certain conditions, the game uses more or less resources in certain other areas. So as an example of this type of change that I want to make in order to kind of facilitate this setup in as smooth of a way as we can make, one thing we need to do is during gameplay loop, like whenever let's see. Or if handle test flag, handle attack sound effects. Okay, so here's the enemy tactics, right? Whenever we spawn like an enemy, you can assign tactics to it in order to control how it behaves. So we're going to swap this so that all enemies that we generate move in random directions only and make no effort to like attack the player. Because just for testing purposes, I'm going to create like a little simulation environment where we have lots of dudes on screen and we can watch them all moving around, bumping into each other and trying to actually, you know, navigate a confined space or a wide space, you know, either way. We can actually start as well by, instead of it being just a 4x4 area, which I was doing for testing only, maybe increase it to like 16x16. And then instead of only one monster, we can actually like add like 9 randomly placed monsters. Why not? You know, that's plenty of you know, like just to see what that looks like for a moment before we scale it up and then take like a profile performance of how the game's actually doing. So we save that. Let's compile and run. Now, something really interesting to note is that I've got it set up so that it's automatically playing. I'm not actually doing any of these controls right now. This is all just automatic random selection. And everything's, you know, behaving pretty smooth. The game feels fast. There's, you know, like everything is just kind of working in a real lockstep fashion. The average draw time over 1,000 draws is pretty locked in at 16.5 milliseconds. So it's not too bad. So seeing that we've got that much going, right? One of the things that we might do is scale it even further, right? So remember that we did a 16x16. What is 16 times 16? Huh? Oh, wow. That shouldn't have shown up. That's funny. Weird. Sixteen times 16 is of course 256. But if we attempt to place 256 monsters in the dungeon, all like in the same spot, it's going to be very crowded and it may not actually fit everybody properly. However, let's try 32 by 32 and see if there's like any apparent slowdown that occurs during game execution. No, it's still going pretty fast. Like, take a look at the bottom right. You can barely see it, but average draw time is 16.1. That's pretty damn impressive, considering we got 255 entities besides player. Besides any items or weapons, there's 255 NPC orcs in this space. And all of the code that's running, like, it's still able to do it this quickly, which is, in my opinion, pretty fucking impressive. What happens if we increase it to a 64 by 64? Oh, we're definitely getting slow down now. Let's see what the average draw time gets up to. Looks like about 20.9, 21 milliseconds. So we're at this, in a 64 by 64 dungeon, we're experiencing that much more, right? So I have an idea. What if we were just, because we're going to experience multiple bottlenecks in this situation. What if we make it a 32 by 32 again, but if we take 32 times 32, that's 1024, and we take half of that, that's 512. So what if we have 512 enemies in a 32 by 32 area? Will we experience any slowdown? That's a good question. No. This is very fast. So it's really not the number of entities in this case. Like I could have 10 entities in a 64 by 64, and the 64 by 64 would still end up being that much slower. I'm guessing. So the real thing that we're trying to optimize in this case for isn't necessarily the number of NPCs, but rather the dimensions of the dungeon itself. And that might make sense, because obviously for each tile yeah, because in many cases, I wonder if there's a way that we can actually speed it up. That's really what I want to know. Because it would be nice to have large sections, like large single floor dungeons, and I mean large. So we're still getting a bit of a slowdown here, right? But the slowdown has become dramatic at 128. So naturally, like I said, it doesn't really matter how many enemies we have in the dungeon so much as how many tiles we have to work with. Oh, that's painfully slow. Oh my god. Experiencing like peaks of like 90 milliseconds. That's disgusting. Our average is already over 30. Oh man, this is just terrible. I can already count on that. Like, my intuition here is probably correct in that the reason that the slowdown is occurring here is because whatever process I'm using where I iterate over each of the tiles, and they said actually update well, okay, so here, okay, now it's time to actually profile, right? So if I want to know where is using like the most stuff, first we gotta run the game. Next, in a separate terminal, we need to get the process ID of the game. I didn't dox myself, did I? Okay, good. All right. Oops. I didn't mean to paste that. I didn't dox myself, did I? Okay, good. Okay, now we're back here. There's our process ID. We have to attach performance or perf to that process. And we're going to sleep for 180 seconds, and we're going to write out to perf 2. So as soon as I do that, I'm going to start running the game again. Like, I mean, the game's already running, but we're going to let it autoplay for like 3 minutes, and perf is going to save a file to out2.perf. And we're going to use that to generate a flame graph to figure out like where shit is currently bottlenecking. Ready? Let's go. So first we hit enter here and we flip back to the game. All right, flip back to the game. I'm going to set a little timer over here. I hope everyone's having a good day today so far. I ultimately decided that, RL text is probably not for me. And while, figuring out like the perfect way to create like a dynamic text rendering system, it's kind of nifty and everything, it might not be the best choice for me. You know what I mean? All right, so just about another minute here. There we go. Okay, so we actually took a lot of samples just now. Let's go ahead and kill the game. All right. So as you can see, it wrote 2 megabytes, which the first time I did it, for like only a minute. Earlier today, it wrote only 0.07 megabytes. I thought, wow, it's impressive how small this stuff is. So now we have our sample. We're going to hop over to my Flamegraph folder. And we're going to copy over the out2.perf file. We're going to run stack collapse perf.pl on that out2.perf. And we're going to save it to out2.folded. And then we're going to run flamegraph.pl on out2.folded. And we're going to save it to kernel2.svg. And then I am going to open kernel2.svg with Brave. And then I'm going to show y'all. We're going to look at it together at the same time. So here is our flame graph. As you can see, like before main happens, there's some crazy shit going on over here in the left-hand side. And we're not going to really worry about that because all that stuff happens before the main, and it's really related to like raylib startup and stuff like that. It's all about like, talking to the graphics card and shit like that. I don't really care about that right now. But taking a look at my core games graph here, we got some really interesting shapes and stuff like that, and we can see obviously a majority of every thing in the game loop ends up actually belonging to a draw frame. And even this sample alone kind of like betrays a bit of the like how much time is actually being spent in certain parts of the code, because we can't even see like the other things that are happening in game loop, right? So we might actually take a second sample. That might be a smart idea here. So hopping back over to let's start by running game. Then we're going to go and set up performance to run for like 1 minute. Maybe even 30 seconds. But we also have to get the process ID. As soon as we hit that, we gotta hop back over. So hopefully with a 30-second sample, we'll get like a better graph. Perfect. Okay. So now we got our graph. Or our sample, I should say. We're going to copy that over. We're going to stack collapse. We're going to flame graph. And then we're going to hop back over here and refresh. This almost looks the same. Here's game state tick. Okay, so in the logic part of the game, oh yeah, update player tiles explored. This would make sense. I was taking a look at this function earlier, and calculate path with thickness was one of the culprits that ended up taking up a lot of time. But if we step back and we take a look at draw frame, you can see that draw frame taking up 97.67% of the of the runtime, and that makes sense. But if we were to take a look and kind of sift out which of these is actually taking up like a lot of time, you know, where are we actually spending most of our time actually running? You know, these are the kinds of questions I want to ask. So we could take a separate sample now, right? I should have saved that other one. Is location too far to draw? It's interesting that that takes up so much CPU time. And then inside of this function, we actually spend a lot of time calling get light radius. It makes sense that, you know, for all the component table accesses, there's a lot of stuff that goes on here, and there's probably a way to make the component table system more efficient, so it's not doing a lot of this crazy kind of stuff. Game state tick, and yeah, so we're gonna take a look at game state tick. Update player tiles explored. Calculate path with thickness. Interesting. All right. All right, so calculate path with thickness. Like, it's right here. And this is the only place in this file that is called. It's probably the only place that is called, period. So as you saw over here, it's called by path blocked right here. So there's path blocked. And path blocked calls calculate path with thickness and dungeon floor tile at. So back over in the actual file, we can correspond that code right here. Path blocked calls calculate path with thickness, as well as dungeon floor tile at. So one thing that would be useful in this process is that if we had a way to cache like the values so that we're not constantly having to like reevaluate this shit, right? This gives me a good opportunity to do a little refactoring. Not the prettiest looking code yet, but this is a good start. So if calculated path with thickness is going to take up so much time, right? Wait a second. I think there's a logic error here. I don't remember why I called it path with thickness. Well, so calculate path with thickness gets called over here when you check to see if path is blocked, right? So path block gets called an update player tiles explored, and that's part of the core game loop. So this is that function right here in the tick, right? So that gets called here. So there's a one-to-one relationship right here. The one thing that I was thinking about doing is that we could seek to like cache these values somehow, right? One thing that we could do for like for instance, calculate path with thickness, or better yet, because specifically path with thickness only depends upon like we're not doing any sort of entity checking. Like we're literally just doing like raw math here. And this is supposed to return a vector. So given a start point and given an end point, like we want to return a whole ass vector, right? And actually this would end up being very computationally expensive. But this is what happens on every game tick. Like on every game tick, path block gets called on every like tile in between the hero and whatever his light radius distance actually is. So path blocked gets called a lot, right? Like update tile explored calls path blocked quite a lot. And path blocked calls calculate path with thickness quite a lot. So this being like the bottom floor, right? Like we can't really do, I mean, well, actually it's kind of interesting. There do seem to be a lot of calls to sort and move. So let's, consider that as we step through this code. So we start off with an empty path, and then we're just adding items to the path. And then we actually... Okay, so the sorting and the uniquing is to, there might be situations where we end up with that stuff, and maybe we could avoid adding them. I mean, we still would end up having to well, we would have to check if they exist in there, right? Because path blocked could change, like the result of path blocked could change on a turn-to-turn basis. You could have an entity or NPC or some other dude moving in and out of your path, which would affect the light. Not to mention you could be moving every single turn as well. So, not to mention there could be other obstacles that get in the way. So caching path block makes no sense. And attempting to store all of the different possibilities for calculate path with thickness would actually get storage expensive over time. So we're probably not going to do that. But Why not? Let's take another profile, right? Like, why is draw frame so fucking slow, right? So get store ends up for this particular situation being kind of expensive. Draw floor entity type is actually so draw frame 2D to texture naturally. This is where a lot of CPU time is being spent over here. And it looks like get store in, let's see, draw dungeon floor entity type. So there's a lot of stuff going on in here too. Back 3 invalid also. Yeah, so there's definitely a lot of opportunity here to optimize a bit. Draw dungeon floor entity type. Let's actually dig into that function, right? Yeah, so there's a big function. Can barely fit it all on the screen. Yeah. It's the reason that this ends up being so computationally expensive. We're calling it all the time. Like, for every single one of these, like, types, we have to call it. It's crazy. So, like, one potential, although this would definitely involve, like, serious stacking of textures and texture layers and things like this, and it might actually make sense to think about doing things this way, because all of this is actually drawing to a specific target texture. Draw frame 2D. So we have like one main texture for that at the moment, and over time, what I'd like to start being able to do is, ideally, hopefully, through the clever use of stacking of target textures and like drawing to certain things and caching everything and kind of doing things in the way that I'm currently doing, but like at a, like a bit more, larger kind of scale, to kind of alleviate some of that slowdown that's occurring during the draw frame when we have large dungeons that we have to navigate through. But taking a look back over here, seeing that, is location too far to draw, right? It would make sense that like maybe we can get away with like not drawing things that are outside of the camera frame. Right? Is location too far to draw? Got this function called Manhattan distance. There's Manhattan distance right there. But as you can see, it doesn't like occupy a whole lot. But is location too far to draw? Does spend a good amount of time in actually getting the light radius. And actually, to call the vec3 invalid, and vec3 equal, like, we could probably All right, let's take another performance profile because I want to. Go and take another sample. Got that going right here. As soon as that's complete, we'll generate another graph. Something in this environment all right, so now that we've got our sample, all right. And here is that flame graph. So we actually skipped the initial seeing entirely before startup, and ends up being a good thing. So zooming in, right? So let's start with game, and then we got draw frame. Draw frame is operating way slower than it should be. So we got draw 2D frame to texture, and that's taking up a lot of time. And actually, it's all the calls to get store on location that are taking up a lot. So we got get store, we got is location too far to draw. We got some some stuff related to the way that the component table works. Calculate path with thickness. This is one of the important reasons why performance really needs to be a super big consideration when you first dive into something. Because while syntactically I was very happy with the result of the component table, and so far so good, if it ends up being that it's the component table that ends up slowing everything down, I'm going to be very sad, because that's going to require some overhaul. The STL does generally solve problems. Generally. So is location too far to draw is actually taking up a good amount of compute here. A lot of stuff going on this left-hand side, man. Update player tiles explored. Oh wow, it's like taking up so little time in comparison to all these other functions. Unordered map equal to yeah, a lot of the ones at this level have to do with the component table. Then is location too far to draw? Like, so at the moment we actually do draw a lot of stuff outside of the the bounds of the camera, which is probably overkill. So in draw frame 2D, actually it's in draw dungeon floor entity type, we're spending like all of this time, right? Why would you have to call get location so much? Is location too far to draw? Okay, so that's what. So we're actually doing this a lot. We actually do not need to call invalid here if we're calling it over there. So that's one less thing that we have to do. And over here, we call this with the assumption that the locations are not invalid. And at this point in the game code, the hero is known not to be invalid. Where are we getting hero location from? Okay. Wait a second. Wait a second. We are doing this way too many times in this loop. Holy shit. I just realized. Holy fuck. We actually do this up here and end up saving a lot of CPU there, right? Num tiles. Where's num tiles coming from? Oh. if we know that the dungeon floor width or height is a power of 2, then we would be able to figure out like bit shifts, right? So one of the reasons it's kind of slow is that we are having to do all of this division and multiplication every iteration. This was kind of silly. I didn't need to do this. One thing I can do to fix it. So first, I'm going to do something kind of silly here. All right, so I'm going to copy and paste this whole loop. This is how I like to do refactoring, right? Two copies of the same piece of code. Step 1, the one we're intending to modify, and the other one we're intending to like keep as a backup copy. For int y equals 0, y less than df h y plus plus. So now we no longer need this inner y. We can comment it out. For int x equals 0. X is less than df w x plus plus. I take all this. So here's the old version, right? I was attempting to be clever and unroll a loop, but this might actually be one of the sources of the slowdowns, is how many times we have to compute that stuff, right? Like if we're having to do a division every single tile just to get or calculate the location that we actually have to look up, or to create the vec3 loc or the loc vector here. Like if we have to divide and multiply in order every single tile to get that value correct, it is going to add up computationally over time. So one thing that we can do go ahead and compile that again. Uh-oh, we got an unused variable. We're no longer using num tiles on 136. Okay. Maybe these small changes will have an impact. Right, so we're getting the process ID. So we could hop back over and then running perf. Now we just have to wait. Okay, so we got an average draw time, and actually I can see that the draw time has gone down already. I think we actually managed to shave off 30 milliseconds from the peak. Although the average is still going up. And over time, the average will settle somewhere in between the minimum and the max here. But any second, this will be complete. All right. So we're going to go ahead and hop back over to our Flamegraph folder. We're going to run stat collapse perf pl on out4, and we are going to run Flamegraph to generate kernel4.svg. Now back in our Flamegraph window, although it still captured that first initial startup thing, which is weird, but okay, whatever. That's fine. So we're gonna hop into main, in our game loop. Then our draw a frame. Draw a frame to texture. Draw a frame 2D. It doesn't look like a whole lot's changed, but so draw done to floor entity type, right? And then is location too far to draw? Yeah, if we're constantly having to get the vision distance for the hero. Yeah, y'all can't see what I'm talking about. If we're constantly having to get the vision distance for the hero, as well as the light radius, naturally this is going to eat up a lot of time. So we really need like a cache of some sort, right? This is my first thought there. Manhattan distance. We've had a few people show up. I'm not necessarily feeling like doing a whole lot more right now for some reason. I suppose I should try to push on. But I really want to see so back over in our flame graph, right? Hmm. 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 I forgot how to do this. Um. Oh yeah, yeah. You have to do star. I got some bounce on the fucking mic. I'll probably take a break here in a little bit to eat. Damn, I got this nasty fucking bruise on my foot from walking so far the other day. Yeah, that's what they actually call a bone spur. What if I set this up for like 3 minutes again so that I could step away and have a little toke as also refresh my coffee and whatnot. That sound okay? All right, we're gonna take samples here. What if we do a 5-minute one? All right, we're taking 5-minute samples. This will hopefully generate an interesting flame graph for us to look at. All right, timer is set, and I will be right back. Okay, samples should be gotten at this point. Yes. Now we hop over here. All right. That's really curious that like it still keeps generating this huge ass fucking thing at the very beginning. Um okay, so here's our flame graph, right? Um draw frame 2D to texture. Draw frame 2D. Calculate path with thickness comes up here again. And draw floor tile. So we can actually more clearly see like what's actually taking up the bulk of our time here. And it looks like calculate path with thickness, like is location path blocked. Calculate path with thickness again up here. So that's curious that draw dungeon floor tile has two different paths that we end up getting to calling calculate path with thickness. So this is kind of unusual. Ideally we would want these like this kind of says to me, okay, so it's like it's only calling it in this case if is location path blocked. So we're like calling it like in like two separate locations, it seems like. It's probably not great. What's happening over here? Shared pointer stuff. Back 3 invalid. That's in draw dungeon floor tile. So it's really draw dungeon floor tile that's potentially, I mean, calculate path with thickness is definitely a bottleneck, but it's relative to draw dungeon floor tile. So it's like each individual floor tile draw is what is potentially expensive here. Because like for every floor, we have to draw, of course, every tile. And then for every entity type, we have to do that. So entity type ends up also consuming a lot of resources here. Let's take a look at draw dungeon floor tile, right? But first,
need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. Till I got my coffee, I'm the motherfucking top B. Motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking coffee. Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I am the motherfucking top B. I need my motherfucking top B. I need my motherfucking coffee. 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 Ain't not a person in the world who can stop me. The corporate world is the devil, I am godly. As long as I got my coffee, I'm the motherfucking top B.
You are now listening to Evil Dojo Dark Mage in the house with the sick flow. You are now listening to Evil Dojo Dark Mage in the house with the sick flow.
All right, we back for a sec. All right, so what did we say? We said Caligate Path of Thickness and draw dungeon floor tile. Okay, so let's hop back. Draw dungeon floor tile. That's right here. And that makes sense. This is like, oh, and also similarly, you know, we attempt to do a similar type of thing here, where this is totally possibly slowing us down, right? So this mildly better, right? Like, and even then, it's not like we're saving a whole lot. DF get width and DF get height. Oof. Now, we've inlined all of these, right? Like, say we draw dungeon floor tile. Now, realistically, we don't need to pass a texture info here because texture info is already available. So because we're not having to pass that function or that pointer around everywhere, you know, it's a little bit, just tiny bit more efficient. So in draw dungeon floor tile, like, oops. Calculate path with sickness. Is being called down here. but then in is path blocked. Like, also, we're not even using path here. Like, what the hell? This is actually doing nothing. That's crazy. I can't believe I had that code in there. So that's why we were seeing calculate paths with thickness in two separate locations. See over here where we had it right here. We also had it over here. Now, when I go to generate like another profile, we're going to see that that's going to be eliminated, and we will have hopefully a moderate or a small, at the very least, a small performance improvement, right? Because we just straight up found a useless line of code, and that's a good thing. So sometimes that happens. All right, step 1, compile it, run. Step 2. Actually, you know what? I kind of want some music in the game right now. Actually, better yet, let's leave the in-game music off and let's listen to some death metal. Alright, so first we do that, and then we set up our perf, right? So first we grab the current process ID for the game. Then we run perf with that process ID. I'm going to copy it into out6. 5 minutes. Okay, we have taken our samples. Let's quit the game. Let's hop back over to our Flamegraph folder. Copy over the new file. Let's do stack collapse. And then let's do flame. All right, now let's open up Flamegraph. Six, kernel 6. All right, there we go. So remember, draw dungeon floor tile was the one that had that little extra call to calculate path with sickness, and it looks like it's gone as expected. Good job, me. That was a relatively low-hanging fruit. And part of the optimization process is going to be, I'll get back in camera for this one because we're almost done here. Part of the optimization process is going to be getting things to work the first time and then going back through, kind of like I'm doing right now, looking for those little opportunities where you can make something just a little bit improved, because maybe you were moving too quickly when you built it the first time, and then you realize, oh shit, I actually didn't mean to do that. So you take the chance to actually fix what you wrote previously, try to align it more with your original intent. And in doing so, I managed to get rid of a line of code that totally didn't need to be there, either because previously it was written in a different context, or for whatever reason, I just had an extra copy to that function call. So that was kind of a win. Let's check that code in. Let's get everything updated, you know, kind of put a pin in this one. And I'm glad that I got to show y'all how to use Flamegraphs, even though we didn't really make like a huge gain on this particular 2-hour venture here. We definitely did something. That's not nothing. So let's get rid of all these old perf things, and then also get rid of perf.data.old. All right, so we actually got rid of a unnecessary variable to draw dungeon floor tile, as well as a unnecessary call to calculate paths with thickness. Then over here, we're attempting to kind of refactor and clean things up a bit. You never actually update X1 and all that stuff, so I'm not going to do anything with this right now, but this is an opportunity for improvement as well. Go back and draw dungeon floor. Like, where do we actually use the XYZ? Is that the only place? Just to grab the tile? So he could actually do that in a level above and then pass the tile in. That way this isn't like hammering. You can always attempt to like unroll some of this loopage, right? Like, generally speaking, like I said previously, every every dungeon floor is going to have a width and a height that's a power of 2, or rather a multiple of 2. Well, maybe it's a power, right? So if we wanted to do 2 at a time, we could do something like this. And if we wanted to do like 4 at a time, we could do something like this. And while we're still spending a lot of time in draw dungeon floor, each one of them has to access like the floor, which, you know, that's a lookup that could be also kind of passed in, I feel like. It's like if we manage to like pass in DF from above, and that way like we can actually eliminate this call, then that's like one less thing that we have to do every turn. If we, instead of constructing a vector 3 here, we pass in a vector 3, then that's one less thing, and we no longer have to check to see if it's invalid in that case. Then we could also use that vector up there to pull in tile at, and then we actually need Loc though, because of the call to Manhattan distance. So in addition to this, every single time we're doing this, we're having to look up like light distance and like light radius for the hero. And that's something that could also be passed in. And, you know, it's like there's definitely a lot of chances for us to propagate some of these calls that we're doing over and over and over again upward in the chain so that like we can use the same value without having to like re-look it up over and over again, which would be very useful. Another example of this would be hero location. We're continuously getting the light distance and the hero location per tile, even though it's not changing on every single draw from tile to tile. So this ends up probably being one of the sources of slowdown, right? Like a lot of this stuff is adding up together in order to create this kind of conflict of interest, right? A lot of this is also happening because of the practice of safe coding that I've been attempting to adhere to, but as a result now I have to consider ways to like squeeze out extra juice here. And even then I'm probably not looking at like the real hardcore bottleneck yet. Yeah. So draw dungeon floor tile though. That's where my attention's at the moment. Got about an hour until it's animal dinner time, and about an hour till it's human dinner time as well. So we've been on for about 2 hours now. And slow progress today, but you know what? It's progress, so I can't shit talk. Those location paths blocked, calls calc path with thickness, and this function, man. I mean, the thing I was thinking about doing that would, you know, kind of uh-oh. Y1. Okay, so everything else can be const, but those two variables have to be integers. And then I'm sure that the sort and the path erase are the most expensive parts of this operation. And actually, this would be a good target for us to try and vibe code something out, right? Taking a look back at the flame graph again for a minute, seeing calculate paths with thickness. Yes, Grace, I know we can see that the sort is what's taking up like the most here. I don't know about the unique, but then what calculate path with thickness, is it calling it again? Unguarded linear insert. Huh. See, I'm not sure why it's like doing it like that. Like why is it organized like that? That's a little bit weird. It's like over here too. Maybe it's just like a reference to like the unique. Okay. You know, instead of returning a path, we could be like using a similar storage location over and over again. Because here is location path blocked. Like we could actually pass, because like the allocation here is definitely taking a lot, right? Like having to return a whole ass vector. My dog's getting upset. She wants me to think about dinner. It's not quite time yet, baby. But we're gonna set back out here in a minute. Draw dungeon floor tile. This is where we are currently focusing. All right, so I've created a checkpoint for myself here so that I can properly get started again, you know, quickly when I'm ready. All right, what do y'all think about that? We actually learn anything cool today? We dig in, pay attention, we fucked around, we found out, we got some stuff done. We all good? Good. Until next time, everybody. DM signing off.